value of x minus 3 is greater than or equal to 4. So, think about greater than. Which way does the graph go? Show me with your hands. Out. Out. No, it does not cross. There will be graphs that cross. This does not. No. It goes this way. This is different. This is different. I'm not doing this. Okay? So, let's do the bottom part of the graph. Tell me how to rewrite this for this part of the graph. Ian. This part of the graph. The bottom part. Less than or equal to negative 4. Then what word? Or, what's the top part going to be? How will I rewrite the top part?
X minus 3 is greater than or equal to positive 4.
Correct. The graph is an or statement. It goes out. So, how do I solve this little inequality here? Add 3 to both sides. So I'm going to have x is less than or equal to negative 1. Or, up here, I'm going to add 3 to both sides. X is greater than or equal to, well, why do I write 4? 7. So, negative 1, 7. I don't think you need to waste your time putting anything else on that graph as far as numbers go. Make sure they're in the right order. So, x is less than or equal to negative 1. Solid circle on negative 1, shaded left. And notice how my shading is a little bit above the line with an arrow so I can clearly read it. The other part, x is greater than or equal to 7. There it is. So any number that is 7 or bigger will make this true. Any number that is negative 1 or less will also make that true. All right. This is a greater than. Think about greater than. What does the graph look like? Out. So, who can tell me the bottom half of the inequality? Correct. Or, Nick? Correct. Solve it. Subtract 2, so x is less than negative 7, or subtract 2, x is greater than 3. So, negative 7 and 3, less than negative 7, open circle, shaded left, greater than 3, open circle, shaded right. So when it is a greater than, it goes out, it is or. And you need to rewrite it as such and then solve. Okay. This one. What do I need to do first before I do any rewriting? Tyson. You need to isolate the absolute value by dividing by 3. So, the absolute value of x plus 4 is greater than 5. Again, it is greater than. Which way does greater than go? Out. Okay, it goes out. So, who can tell me what the bottom half will be? Katrina? Or, what will the top part be? Correct. Solve it. Subtract 4, so x is less than negative 9, or subtract 4, x is greater than 1. So, negative 9, open circle, shaded left, and 1, open circle, shaded right. Okay, number 4. What will you do first in number 4? Correct. Let's isolate the absolute value. So I'm going to have the absolute value of x plus 6 is less than or equal to 1. Okay, this is the first less than we did. Show me what less than looks like with your hands. In between. So, what am I going to write down here? No, what goes first? Small one. Not positive 1. Negative 1. Less than or equal to plus 6. And that's less than or equal to 1. It goes in. Right? So, start with the small end, which will be negative 1. So, this is red. X plus 6 is greater than or equal to negative 1, and x plus 6 is less than or equal to 1. When you write a combined inequality, you always start with the smallest number and work your way up. And use less than. Always. This is between those. Now, what do I do now? So, this will be negative 7 is less than or equal to x, and that's less than or equal to negative 5. So I'm going to have negative 7, negative 5. What type of circles are that? Closed, and where is the shading? In between. Because we are looking for the numbers that are greater than negative 7 and less than negative 5. Right there. No arrows. Yes. Could be negative 6.1. It could be any number in here. So let's try negative 6. Negative 6, let's go back to the original problem. Let me erase this so we can see it clearly. If I put negative 6 in, negative 6 plus 6 is 0. The absolute value of 0 is 0. Plus 6 is 6. Is 6 less than or equal to 7? Yes. How about if I put negative, what else could work? Negative 5 will work because it is equal to. Negative 5 plus 6 is 1. The absolute value of 1 is 1. 1 plus 6 is 7. Is 7 less than or equal to 7? Yes. And I could also put in negative 7. It would work out exactly the same. Or I could put in negative 5.2 or negative 6.9. Any number in here will work. Yes. Okay. Yes. Let me see what's coming up here. There's that. So, let me make up a problem. I'm hoping that this will work. Let me think. Okay, might work. Let's see. Okay. So, what kind of problem is this? Which way is greater than God? So, who can give me the bottom part, Katrina? Correct, because if it's going out, it needs to be less than the negative. Or, I think this is going to be a great problem if it works out the way I want. What's the top part? Correct. So, let's solve this. Subtract 3. So I'm going to have negative 2x. I could have made this so it worked out evenly, but whatever. Negative 9. Divide both sides by negative 2. What happens when I divide by a negative? Switch. So if I multiply or divide by a negative, I need to switch the inequality. So I'm going to have x is greater than or equal to, what is that, 4.5? It's going to be positive, because a negative divided by negative is positive. Okay, over here, let's subtract 3 from both sides. So I'm going to have negative 2x is greater than or equal to 3. I'm going to divide by negative 2. I'm going to have x is switch this, less than or equal to negative 1.5. Now, look how awesome this is. Here's negative 1.5. Here's 4.5. X is greater than or equal to 4.5. Solid circle, shaded right. X is less than or equal to negative 5, 1.5. Still goes out. But the one that you expected to be the bottom actually becomes the top. And the one that you expected to be the top actually becomes the bottom. So what's that? Now, let me pause this. And then I want to show you something.